Today we're going to learn how to multiply and divide with radicals. You should be on page 19 in your notes packet. When multiplying radicals, you are just simply going to multiply any coefficients, multiply the radicals, and then simplify. In many cases, it's going to be easier if you simplify before you start multiplying. For the example, the square root of 18 times the square root of 12, I'm going to start by asking myself if these can be simplified. So if I start with the square root of 18, I know that there is a perfect square of 9 and 18. So the square root of 18 can really be changed to the square root of 9 times the square root of 2. Then I'm taking this and multiplying by the square root of 12. Well, I know that the square root of 12 has a perfect square of 4. So I can change that into the square root of 4 times the square root of 3. Then I just want to simplify anything. Well, the square root of 9 is 3. The square root of 2 is not a perfect square, so I'm going to leave it the way that it is. Then for the square root of 12, the square root of 4 is 2. The square root of 3 is not a perfect square, so I'm leaving it inside the radical. Now all I've done at this point is rewritten the original problem so that it was in more simple terms. Now to solve it, all I have to do is multiply my coefficients, which are the numbers multiplied by the radical. So I'm going to multiply 3 times 2. Well, 3 times 2 is going to give me 6. Then I'm going to multiply the numbers in the radical. So now I'm going to multiply the square root of 2 times the square root of 3. The square root of 2 times the square root of 3 gives me the square root of 6. This last step is very important. It's always imperative that you check your radical and make sure that it cannot be simplified. When I think of the number 6, I know that its only factors are 1, 2, 3, and 6. Since none of those are perfect squares, I know that this is in simplest form. So my solution is 6 times the square root of 6. You could have also gotten this answer by not simplifying to begin with. If you had just done the square root of 18 times the square root of 12, well, 18 times 12 gives you 216. If you list out all of the factors of 216, you'll find that its greatest factor that is also a perfect square is 36, because 216 can be written as the square root of 36 times the square root of 6. If you simplified the square root of 36, you would get 6. This 6 would have to stay in the radical, and so your answer would still be 6 times the square root of 6. The reason that I began with this problem by simplifying is because it gave me smaller numbers to work with inside of my radical, which typically makes simplifying at the end easier. Our next problem says 2 times the square root of 5 times 4 times the square root of 20. Again, for this one, you can multiply straight out or you can simplify first. If we multiply to begin with, we have our coefficient of 2 times our coefficient of 4. 2 times 4 would give us 8. Then we would multiply our radicals. So we would multiply the square root of 5 times the square root of 20. Well, the square root of 5 times the square root of 20 would give us the square root of 100. Then we would need to simplify this. Well, 100 is a perfect square, so I can just find the square root of 100, which is 10. So this really says 8 times 10, which would give me a solution of 80. If you had simplified this to start with, you would have found that there's nothing you could do to the square root of 5, so you would just rewrite 2 times the square root of 5. But for 4 times the square root of 20, we know that there is a perfect square of 4 that will go into 20. So 20 can be rewritten as the square root of 4 times the square root of 5. Well, again, we're just rewriting 2 times the square root of 5, and we're multiplying it times 4 times the square root of 20, but I've changed that. Well, we still have this 4, and the square root of 4 is 2, and then we still have the square root of 5. Well, now we have 2 times the square root of 5 times 4 times 2 gives us 8, and then 8 times the square root of 5. If I multiplied here, I would do 2 times 8 because they are my coefficients. So 2 times 8 gives me 16. Then I'm going to multiply the square root of 5 times the square root of 5. Well, the square root of 5 times the square root of 5 gives me the square root of 25. But this can also be simplified because 25 is a perfect square. The square root of 25 is 5, so this really says 16 times 5, which equals 80. It is your choice of whether you want to go ahead and just multiply straight out or whether you would like to simplify first. Sometimes, certain problems, it's easier to do one thing or the other. For the last problem under multiplying, you see 3 times the square root of 32 times 4 times the square root of 6. Well, for this problem, I probably would simplify my 32, but we can also go and just multiply straight out. So let's look at our answers, or our two different choices. If we multiply straight out, we're going to multiply 3 times 4, which gives us 12. Then we're going to multiply the square root of 32 times the square root of 6, which gives us 192. Well, now all we're going to do is try to think about a perfect square that will go into 192. Well, if we think about perfect squares that go into 192, we know that 64 is the greatest perfect square that goes into 192, and it goes into that 3 times. So this can be rewritten as 12 times the square root of 64 times the square root of 3. We know that the square root of 64 is 8, so it's really 12 times 8 times the square root of 3. 12 times 8 is 96, so our solution would be 96 times the square root of 3. If you had simplified to begin with, you would have gotten 3 times the square root of 16 times the square root of 2, because 32 can be changed into 16 times 2. The square root of 6 cannot be simplified, so you would just rewrite it just like this. The square root of 16 is 4, so this is really saying 3 times 4 times the square root of 2. And again, 4 times the square root of 6 cannot be changed. 3 times 4 would be 12, so you're really looking at 12 times the square root of 2 times 4 times the square root of 6. Then you would multiply your coefficient of 12 times 4, which would give us 48. And then the square root of 2 times the square root of 6, which would give us the square root of 12. This can be simplified because there is a perfect square that will go into 12. We know that 12 can actually be rewritten as the square root of 4 times the square root of 3. Well, the square root of 4 is 2, so this is like saying 48 times 2 times the square root of 3. And then we would simplify. 48 times 2 is 96, and our solution would be 96 times the square root of 3. So whichever way you do this, you should still get the same answer. To divide radicals, you are going to look at coefficients first, if you have any coefficients. If you have them, you would divide them if they can be divided. If you have radicals, you're going to divide the radicals if they can be divided. If they cannot be divided, you also want to look for common factors. So also divide common factors which will cancel each other out. So let's start with the square root of 126 over the square root of 7. We know that this fraction bar tells us to divide. Well, if I divide 126 by 7, I am going to get 18. Now, remember, these are both inside radicals, so I'm not really getting 18. What I'm really getting is the square root of 18. Now, we know that we always need to simplify. Well, I know that there is a perfect square of 9 that will go into 18, so 18 can be rewritten as the square root of 9 times the square root of 2. The square root of 9 is 3, so this is really 3 times the square root of 2. For 21 times the square root of 80 over 3 times the square root of 5, we have coefficients, so we're going to start with that. Well, we know that 21 is divisible by 3, so we're going to do 21 divided by 3. That's going to give us a new coefficient of 7. Then we're going to look at our radicals. Well, we know that 80 is divisible by 5, and 80 divided by 5 is 16. So the radical is a square root of 16. Well, again, we need to simplify, and since 16 is a perfect square, I can just solve the square root of 16. I know that the square root of 16 is 4, so this really says 7 times 4, which gives us a solution of 28. For the square root of 45 divided by the square root of 27, we know that 45 is not divisible by 27. So what I'm going to do instead is think about some common factors between 45 and 27. Well, the greatest common factor for 45 and 27 is 9. So let's rewrite both of these using radicals of 9. The square root of 45 can be rewritten as the square root of 9 times the square root of 5. The square root of 27 can be rewritten as the square root of 9 times the square root of 3. Now at this point, we typically would take the square root of 9 out of the radical because it's a perfect square. But we don't actually need to do that step here because the square root of 9 divided by the square root of 9 is 1. They really will just cancel each other out. That means that what we're really left with is the square root of 5 over the square root of 3. However, if you read step 3 carefully, when we simplify, we can never leave a radical in the denominator. We have to do what is called rationalizing the denominator. To rationalize the denominator, we are going to multiply both the numerator and the denominator by the same number. And that number is whatever we have in our radical in our denominator. So in this case, since we have the square root of 3 in our denominator, we're going to multiply by the square root of 3 over the square root of 3. Technically, this is multiplying by 1, so it does not change the value here, but what this will do is eliminate my radical in the denominator. The square root of 5 times the square root of 3 gives us the square root of 15. The square root of 3 times the square root of 3 gives us the square root of 9. Well, we know that the square root of 9 is actually 3 because 9 is a perfect square. So this is the square root of 15 over, since the square root of 9 is 3, we're going to pull it out of the radical. Now we always want to check and make sure that nothing else can be simplified. Our radical of 15 does not have any factors that are perfect squares. Because there are no factors that are perfect squares, this is completely simplified. If you look at your answer and your answer has a radical in the denominator, then your answer is not in simplest form. So it's very important that you always rationalize the denominator. For the square root of 21 divided by the square root of 27, we know that neither of these can be divided by the others, so we're going to look for some common factors. Well, when I think about 21 and 27, I know that they have a common factor of 3. So I'm going to rewrite the square root of 21 as the square root of 3 times the square root of 7. Then I'm going to rewrite the square root of 27 as the square root of 3 times the square root of 9. Well, when I look at this, I have a common factor of the square root of 3. That means that those two will cancel each other out. What I'm really left with is the square root of 7 over the square root of 9. Well, when I look at the square root of 9, I know that 9 is a perfect square. So I would really rewrite the square root of 9 as 3. The square root of 7 cannot be rewritten because it's not a perfect square and there are no factors that are perfect squares. But the square root of 9 is equal to 3, so it will become out of its radical. Since this number does not have a radical in the denominator, and since the square root of 7 cannot be simplified, this is our answer in simplest form. For 30 times the square root of 2 divided by the square root of 3, we know that we would start by looking at our coefficients. But since we don't have a coefficient, which means there's actually an invisible coefficient of 1 here, we can't really simplify our 30. We also can't simplify our 2 or our 3. Neither of those has a factor that is a perfect square, and neither of those has a common factor that we can pull out. So, because of that, this is almost in simplest form. However, we know that our answers cannot be in simplest form if we have a radical in our denominator. Since we have this square root of 3 in our denominator, we have to get rid of it. The way that we get rid of that is by rationalizing the denominator. We are going to multiply both the numerator and the denominator by the square root of 3. So we will multiply by the square root of 3 over the square root of 3. Well, 30 doesn't have anything to be multiplied by, so we are just going to rewrite 30. Then the square root of 2 times the square root of 3 gives us the square root of 6. The square root of 3 times the square root of 3 gives us the square root of 9. Well, we know that the square root of 9 is actually 3. So we haven't done anything to our numerator, but we know that the square root of 9 can be rewritten as 3. Well, now when you look at this, we have two whole numbers, and we need to check to see if that can be simplified. Well, we know that if we did 30 divided by 3, we would actually get 10. So this would become 10. Now our square root of 6 no longer can be simplified, so we keep it in the radical. Since we did 30 divided by 3, we got rid of our denominator altogether, and our solution is 10 times the square root of 6. For the square root of 72 over the square root of 80, we know that 72 cannot be divided by 80, so instead we're going to look for common factors between 72 and 80. Well, we know that both of these numbers are divisible by 8. If I rewrote the square root of 72, I would say the square root of 8 times the square root of 9. And if I rewrote 80, I would write the square root of 8 times the square root of 10. Well, our square root of 8 would cancel, and I would really be left with the square root of 9 over the square root of 10. Well, the square root of 9 also can be simplified since 9 is a perfect square. The square root of 9 is 3, and now we have 3 over the square root of 10. Now this is almost simplified. However, the square root of 10 cannot be left in the denominator because we can never have a radical in the denominator. So to fix that, I'm going to take 3 over the square root of 10, and I'm going to multiply by my square root of 10. So I'm going to multiply by the square root of 10 over the square root of 10. 3 times the square root of 10 is just going to remain 3 times the square root of 10. Since 3 was a whole number and 10 was in a radical, they can't be combined, so we would just write them like this. The square root of 10 times the square root of 10 gives us the square root of 100. Well, then we just need to simplify, and we know that the square root of 100 is 10, So we would put a 10 here. Now we would want to check our coefficients or our whole numbers, but when I look at 3 over 10, I know that they don't have any factors in common. So I know that I cannot simplify anything with my whole numbers. My square root of 10 does not have any factors that are perfect squares, so that is also in simplest form. Since my coefficients cannot be simplified and my radicals cannot be simplified, that means that this is my solution.